Welcome back. In this video we're going to explore the mean value theorem. What the mean value theorem establishes is it establishes where on an interval a tangent line would be parallel to a secant line. But there's a couple of things that you have to worry about first. The function has to be continuous and it has to be differentiable. To prove the mean value theorem, we start with Rolle's theorem. So let's take a look at that one first. So what Rolle's theorem says is that if you have a function f is continuous on a closed interval, a to b, and it's differentiable on an open interval from a to b, and if f of a equals f of b, then the derivative has to equal 0 for at least one number c in the interval between a and b. This picture makes more sense of it. So here's a f of a up here, and here's b f of b, and these are equal to each other. If this function is continuous and you can find the derivative on the whole interval, then somewhere it has to have this turning point. So Rolle's theorem establishes that this value c exists, that it has that turning point. In this particular picture, it has another turning point over here that also satisfies Rolle's theorem. So I could use either one of them, but the way it's drawn, I just have one, they have one identified. So in the first example, I'm going to apply Rolle's theorem on the interval between 1 and 4 of this equation. If I calculate f of 1, I find that that is 13. If I calculate f of 4, I also find that is 13. So therefore, this establishes Rolle's theorem is true. The prerequisites for Rolle's theorem, that a function is continuous and that it also that f of a equals f of b, those are both satisfied. A polynomial function, something like 4x squared minus 20x plus 29, that is going to be a continuous function, no problem, because it's a polynomial in all values. So if I take the derivative f prime, and let's call it c to use a proper notation, it's going to be 8c minus 20. And what I have to find is that equals 0. And that does occur at c equals 5 over 2, or 2.5. And that does fall in the interval between 1 and 4. So that's the conclusion for Rolle's theorem. Now, in the mean value theorem, it doesn't have to be that f of a equals f of b. F of a does not have to equal f of b. A and b could be these values here, where the line is what we call a secant line, connects the 2 points on the graph, and it has a particular slope. And what it says is that if the function is continuous and differentiable on a to b, and then therefore then the tangent line, the slope of the tangent line, has to be equal to the slope of the secant line somewhere on that interval. In this picture, what you can see is there. This is going to become a more important concept when you look at economics a little bit later on in the class. So in this first one, I have a polynomial function, so it is going to be continuous. If I find, I want to find the value of c in this interval between -1 and 4, so I've got to calculate what is f of -1. And when I calculated f of -1, I got 1.25. And if I calculate f of 4, I got 5. If I find the derivative, f prime of c, that's going to be 1/2 of c. And that's going to be equal to the slope of that secant line. So 5 minus 1.25 over 4 minus -1. When I solve that, I got c to be 1.5. 1.5 is in the interval between -1 and 4, so you're good to go. Same idea in this one. It's a polynomial function, so it is continuous and differentiable on all values. So calculate f of 1. I calculated f of 1 to be -2, f of 5 to be 66. The derivative f of c is 6c minus 1, and that's going to have to equal the slope of this secant line, which is going to be 66 minus -2 over 5 minus 1. In this particular case, it's going to be 6c minus 1 equals 17, so c equaled 3. 3 does fall in the interval between 1 and 5, so that's the conclusion of the mean value theorem. And then finally, my last one, this time I'm going to describe it. I had the derivative given to me as this. I know that x has got to be greater than 0. I know that f of 1 equals 9, and I know that f of 3 equals 11. And I want to find the value of x in the open interval between 1 and 3 that satisfies the mean value theorem. So if I find the slope of the secant line between x equals 1 and x equals 3 is going to be 11 minus 9 over 3 minus 1, which is 1. Now when I set that equal to the derivative, which is 3x squared minus 6 over x squared, when I solve that, I end up with x equals plus or minus the square root of 3. But I don't have to worry about the negative square root of 3 for a couple of reasons. Number one, x has got to be greater than 0. And then number two, it has to be in the interval between 1 and 3. So only x equals square root of 3 satisfies that. All right, mean value theorem will peek its head out throughout this class, throughout the rest of this class. Sometimes we kind of hide it, but the original concepts are not too hard, not too bad to work with. Good luck. See you in class.